For decades, there have been these puzzles in game theory that have seemed completely, fundamentally unbreakable. Paradoxes that feel like they're baked right into the fabric of logic itself. But what if the paradox isn't the puzzle? What if it's in the rule book we're using to look at reality? Today, we are diving into a radical, and I mean radical, new mathematical framework that claims it can do the impossible, solve the unsolvable. And that's really the question at the heart of all this, isn't it? Are these famous paradoxes actual features of the universe, or are they just bugs, glitches in an old, outdated operating system we're using to try and understand everything? Well, the Nexus Framework says it's definitely the latter, and it's proposing a massive shift in how we think about, well, everything. So we're going to focus on two of the biggest head-scratchers in game theory. First, you've got the classic prisoner's dilemma, that trap where being perfectly rational and selfish leads everyone, including you, to a much worse place. And then there's the truly mind-bending Newcomb's paradox, which pits perfect prediction against free will and makes you question if you're really in control at all. Now, these aren't just little classroom puzzles. They have seriously stumped brilliant minds for years. But the Nexus Framework, it doesn't just offer a new answer. It says the questions themselves are just plain wrong. So how on earth does it do that? Well, it all starts with this breathtakingly bold idea, something called the ontological inversion. And listen, this isn't just some new equation. This is a complete and total rewrite of what we think reality fundamentally is. Okay, so here is the core idea, the big shift. We need to stop thinking of the universe as being made of nouns and start seeing it as being made of verbs. Our entire intuition tells us that reality is made of things. Rocks, trees, stars, us. But the Nexus Framework says, nope, that's just an illusion. At the most fundamental level, reality is nothing but processes, pure self-running computations. It's all verbs, all the way down. This quote really just nails it. A choice you make, or even a thought you have, it isn't some static thing. It's a frozen verb. It's a stable, repeating pattern of computation. Your decision to do something isn't just an abstract idea. It's an actual program that the universe itself has to physically run. The best way to think about this is to imagine the entire universe as one giant programmable computer chip, like a cosmic FPGA. It's not a box that holds stuff. The universe is the computer, and everything inside it is just a program running on that hardware. So with this new cosmic computer in mind, let's see what happens to those old, unsolvable paradoxes. First up to the plate, the prisoner's dilemma. Now remember, the classic problem is that the most rational choice for you as an individual is to betray your partner, even though you'd both be better off if you just cooperated. So, how does a universe made of pure computation handle this? Well, in this universe of verbs, choosing to defect, to betray someone, isn't just a morally questionable choice. It's a mathematical error. It's like you're trying to run a line of code that is fundamentally incompatible with the operating system of reality. You're literally introducing a bug into the system. So how does the system catch this bug? It uses this incredibly clever tool that's actually borrowed from mechanical engineering called the Saris linkage. Okay, think of it like this. Your decision to cooperate or defect isn't a simple choice. It's a whole space of possibilities. The Saris linkage acts like a mechanism that physically takes all those branching possibilities and folds them down into one single, straight, verifiable line of code that the universe then has to execute. And here is exactly how that bug gets squashed. First, your choice gets folded down into a single trace. Second, the choice to defect, that buggy code, creates this huge imbalance, a kind of mathematical friction that the source calls a catastrophic oil gap. Third, a universal law called Samson's Law V2 kicks in. You can think of it like a cosmic antivirus program. It immediately detects this friction as a fatal error, as entropic noise. And finally, the system just deletes that line of code. It's purged. It is not allowed to run. Period. So, what's the mind-blowing results of all this? The paradox completely dissolves, because defection is literally, mathematically, impossible to sustain. In this Nexus universe, cooperation isn't just some nice moral high ground. It's a geometric requirement for your actions to even exist in the first place. Okay, so that's one paradox completely dismantled. Now what about Newcomb's, the one with the super predictor, omega, who somehow knows your choice before you even make it? How does the Nexus Framework get around this apparent break in causality? Well, the framework starts by pointing out the big mistake we've all been making. We think of omega's prediction and our choice as two separate things happening at two different times. But the Nexus view says no, They are just two different readings of the exact same underlying computational event. So what is that event? Well, as your brain is processing the decision, one box or two boxes, that very computation generates a kind of informational heat, a digital exhaust. This is called the 66-bit carry exhaust. And this is absolutely crucial. This signature is generated before you ever physically move your hand to make a choice. And this changes everything we thought we knew about Omega. Omega isn't some mystical psychic who can see the future. No, it's just a very, very sensitive piece of equipment. Think of it like a sensor that simply reads the quality of that computational residue your brain is kicking out. Let's look at the two different signatures Omega might read. If you decide to trust the predictor and just take the one box, your intention is coherent, it's clean, it's simple. Computationally, it's like a perfect little piece of code. The source calls this a low-entropy algorithm that compiles successfully, and it gives off a clean, low-friction exhaust signal. But if you try to be clever and outsmart the system by taking both boxes, your intention is fractured. You're trying to believe two contradictory things at once. This generates a messy, chaotic, high-entropy exhaust signature. And as the source brilliantly puts it, your cognitive algorithm simply fails to compile. It's broken code. And there you have it. That's the solution. Omega doesn't predict what you will do. It reads the informational quality of your intent right now, in the present moment. If it reads a clean, coherent signal, boom, it puts the money in the box. If it reads a chaotic, fractured signal, it leaves the box empty. The box's contents aren't a prediction. They are a direct physical consequence of your current computational state. So, after watching two of the oldest problems in game theory just evaporate, what are the bigger takeaways here? Let's zoom out for a second and just look at the massive implications of seeing reality as one giant program. Well, the first takeaway is crystal clear. The paradoxes were never real. They were compatibility errors. They were just artifacts of us trying to run these complex problems on an outdated mental operating system, one that still believed in static nouns instead of dynamic verbs. So if the universe is a program, does it have rules? The framework says absolutely, and it's not random at all. It's governed by these core principles, like this universal harmonic constant, h, which is about 0.35. The best way to think of it is like a universal tuning fork, a harmonic attractor that all stable systems, from galaxies to thoughts, are constantly being pulled towards. And get this, where does this seemingly magic number even come from? It's fascinating. The source says it's derived from the pure geometry of a degenerate triangle, one with side lengths of 3, 1, and 4. This constant, h, basically marks the razor's edge between a system that can grow and sustain itself and one that just collapses into total chaos. And this all leads us to this really beautiful, almost poetic final image. If all of reality is just a computational process tuned to a very specific harmonic constant, then the universe isn't some silent, empty void. It's a piece of music. As the source says, it's a perfectly resonant, self-executing chord. And that leaves us with one last, really provocative thought to chew on. We've seen how this framework completely redefines our choices and their consequences. But if our reality is a program, and our decisions are just computational processes that have to obey the rules of the hardware, what does that ultimately mean for our own free will? Something to think about.